In the first video, we proved theorem 5 and did like 3 basic examples. Theorem 6 is it's the same one, but it's actually like a chain rule added to what we just talked about. So in an example, they are very easy. So if you have y equals e to the 4x, okay, what you have to do is you have to take the derivative of the big function, okay, which is e to the 4x. So you will write down e to the 4x first, okay? But you must multiply this by the derivative of the inside function, which is 4x. So whenever you're finding the derivative of these exponential functions with base e, you copy down that function exactly the same ones, and then you multiply this by the derivative of its exponent. Okay, don't worry, we'll practice more. So this becomes y equals e to the 4x times 4, right? So you can write your final answer as y equals 4 times e to the 4x. You will notice the pattern. That coefficient in the exponent, this 4, it just came down. So I can tell you that that's what's going to happen. The exponent in the the coefficient in that exponent, it just comes down. That's really what it is. So if I give you some shortcuts, like suppose you have y equals e to the 7x. Okay, suppose you have that. Guess what? The derivative of that is simply 7 e to the 7x. Okay, that's the rule. I think I'll erase that. All right, let me do a couple more with you. So this is chain rule at it. So it's the shortcut. The short way to doing it is that's 3 will just come down, right? The 3 will come down, but there is 7 in front of it already. So I have to multiply 7 times 3 and get 21. And I need to write down e to the 3x. This is not really a power rule, okay? I'm not making this 3x minus 1 or 2x. I'm not changing this original exponent. You have to keep it the same. So that's the answer. But if you want to do it the long way, I don't know if you really need to, you have to do y equals 7 times derivative of e to the 3x, which is 7 times e to the 3x. You write down that exponential term, but you need to now multiply that by the derivative of the exponent, which is 3x. And that becomes 7 times e to the 3x times 3. And when you finally multiply that 7 times 3, you will get 21 e to the 3x. So that's the long reason behind it, but you can get that same answer by just doing the 7 times 3, write down that 21, but keep that exponential term exactly the same. I wouldn't do like all this work, but just wanted to show you at least once where this answer came from, okay? All right, I'm gonna go ahead and just do the shortcut method on the other ones now. C, ooh, what do you think this will give us? So you have to multiply -4 times 7. Okay, that will be y prime equals -28. Keep the exponential term exactly the same. E to the 7x power. That's it. All right, let's look at D. I need to multiply this 5 by this 4. So you have y prime equals 20 e to the 4x power. Don't change that original exponent. Keep it exactly the same. And if you're wondering why is that true, take a look at part B, what we did. It's very similar to that, okay? But even if it looks like the exponent is just a monomial, like a linear term, this method will work. All right, last two, I have to multiply -10 times +½ So y prime is -5 e to the ½ x. All right, let's do the last one. Ooh, I need to multiply quarter times 4. What is quarter times 4? That is just 1 e to the 4x. And we can just write that as y prime equals e to the 4x. But showed you 4 examples based on theorem number 6. So the general rule is if you're taking a derivative of e to the f of x, that we have a function as an exponent instead of just x, like 2x, 4x, 7x for that case, 4x. Oh, then you have to write down that same exact term once, but you must multiply that by the derivative of that exponent, okay? We should see a couple more examples. Do I have something similar? Yeah. All right, let me see. Yeah, I think I'm gonna go ahead and keep on going. Page number 3. So on this page, let's review power rule, product rule, and quotient rule from chapter 1. So the first one, I have y equals x to the 4th power. So if I'm taking the derivative of this, okay, they didn't really say differentiate, but I guess that is the direction. Y prime is, first, this one's super easy, isn't it? X to the 4th power, the derivative of that is 4x to the 3rd power. Now the new guy, the second term is what we just talked about in this lesson. I need to multiply this negative 5 by 4, and that will give me minus 20 and e raised to the 4x power, and that is the answer. Okay, not bad. But what's next? Ooh, okay. Do you see a product? This is a product. Okay, I'm gonna call this piece, this trinomial, my f, and I'm gonna call this e of x my g. I can see a product. Okay, it's a product of f and g. So we will use the product rule. Product rule says y prime is fg prime plus gf prime. I graded 17 tests so far, and I had 13 A's so far out of those 17. So, and product rule was one rule that almost all of you got right. So I think you guys are very good with product rules. So instead of listing the pieces, let me just go ahead and do this with you. F is 3x squared minus 5x plus 2. Now, g prime is just e to the x, isn't it? Because derivative of e to the x is just e to the x. Plus sign. I need g this time. G is e to the x. And I must multiply this by the derivative of the first piece. F prime is going to be 6x minus 5, right? 6x minus 5, yup. Now I'll show you how you can simplify this. You notice that they both have e to the x power, right? Factor that out. Bring that e to the x out to the front. They both have it, so we will take it out as their greatest common factor. So what's left inside? I have 3x squared minus 5x plus 2. We have the plus sign. And we have 6x minus 5 inside. And it looks like we can simplify the like terms inside this parenthesis. So what is our final answer? We'll have our e to the x, 3x squared plus x minus 3. And that's where I would stop for this problem. We were using the product rule. And if I'm, okay, I'll go back and write down the pieces. We used f to be that first piece of multiplication. When we take the derivative of that, we got 6x minus 5, right? And we said the second piece that's getting multiplied is e to the x. And by theorem 5, derivative of that is just e to the x. So using those four product rule pieces, we were able to simplify we were able to find the derivative and simplify by factoring out e to the x and combining some like terms. I think this problem was really cute. All right, let's do one more. I think one should be enough. Yeah, this one is a product rule problem. You can see that the product is x squared times e to the 4x, right? So we have a product rule, so I should use the product rule again. Okay, so first I'll say f is x squared, then f prime is 2x. I'll say g is e to the 4x. How do you take the derivative of that? You learned it on the previous page, right? That is 4 e to the 4x. So let's do the product rule. Y prime is fg prime plus gf prime. So let's plug in all these pieces. Y prime is f first, x squared times, let me go ahead and put all of these in the parentheses. X squared times 4 times e to the 4x. So if these were like terms that are multiplying, I just, how should I say, I just put them each in parentheses. I multiplied this times this. I just put the 4 in its separate parentheses, okay? Next, I need to do plus g times e to the 4x times f prime, which is 2x. 2 times x. Maybe I shouldn't have put them in like separate parentheses, but all right, it's okay. What can I factor out? Again, I can factor out this e to the 4x. That e term can be factored out. So I'll write down e to the 4x outside. So what's left inside? If this gray underlined part comes out, do you notice there is x squared times 4 left inside? X squared times 4 is 4x squared. Plus sign. E to the 4x, this gray underlined term comes out. What's left? We got 2x left. 2x. And this looks perfect. I will stop here. This is simplified all the way. You know what? I've noticed that you guys are so good at factoring. So maybe you may want to factor out 2x from it if you want to. So if I factor out the 2x, I will place that 2x in front of that exponential term. And then I will have what left? I will have 2x plus 1 left. But this last line is really just optional. You don't really have to factor it out. I think that this line looked beautiful too. But that's it. That's how you would do product rule and power rule. And on my next video, I will show you how to do these quotient rule problem or chain rule problem involving exponential function with base e.